Hey kids, welcome to lesson 25 in module 2. Still in module 2, wrapping things up and working on division for a while. So the objective of this lesson is we're learning decimal division with 2-digit divisors. Here's the divisor. And we're reasoning about the placement of the decimal. So I want you to think about the size of the dividend compared with the size of the divisor. They're going to give you a lot of similar numbers, but not the same. So if we take our first sample problem of 39 and 1/10, that's roughly 40, okay? But, sorry, I should probably say, let's round the divisor first, which is what I've been saying for quite a while. So you want to look for what you will round the divisor to, and then choose a compatible number. So 17 could round easily to 20, and then skip count by 20 2 times to get 40. That's why it makes sense to turn 39 into 40. When you have 40 divided by 20, you would easily get 2. Now that's real nice for the whole numbers, but what happens when you have a number like 3? Well, it's still got the 3, the 9, the 1, 391, but the decimal has shifted, so this number is only 1/10 the size of this number. Same divisor. So the divisor, when you round it first, is still 20, but you end up with 4 as your dividend. Now, don't panic. You can divide numbers of any size by a number of any size. And in the previous lesson, in lesson 24, we learned that we can take this divisor apart and use a two-step method. So taking 4 divided by 2 to give you the 2, and then divide by 10, no problem there. 2 divided by 10 is 2/10. And that should make sense because if my dividend is 1/10 the size, then my quotient should be 1/10 the size. So here's another one. 63 and 6/10 divided by 73. Round the divisor first to 70 makes sense. Look for a multiple of 7, and 63 is a multiple of 7. If you know your facts, these are going to be easy. If you don't know your facts, it always will present a bit of a challenge. So taking your divisor again and breaking it into 2 pieces, take the 63 divided by 7 first, then divide by 10. You get 9, then divide by 10 for 9/10. And another sample problem, and then, well, if you want to make a tape diagram, you can look at the size of what 1 is. And so just really understanding, if I have 9/10, I have 1 that's broken into 10 parts, and I'm taking 9 of them or identifying 9 of them. So that's what that means, like fractional numbers. If I have something that is the size of 63 being divided by something that's a little bit bigger, I should get almost 1. So that's just a visual representation of what almost 1 looks like. Last sample problem, 11 and 72/100 divided by 42. So round the divisor first. Notice that you get the 4 in 40, and the 4 is what you want to skip count by to get an even multiple of this number. So round 11 and 72/100 to 12, and when you have 12.00, you don't have to write this 0.00. You can just drop it right off because 12 ones or any whole number, if you have zeros after the decimal, you can just leave them out. So then you take your 12 and you divide by, instead of 40, the 4 first, then the 10. Then you get your quick and easy fact, like the fact family facts, 3 divide by 10 for 3/10. Okay? And then finally, thinking about if I have 12 and I have to divide it into 42 pieces, so the pieces are going to be very small. So 3/10 would be only these 3. That's the size of 3/10 compared to 1. So that makes sense because 12 is not very big, but 42 is pretty big. So just thinking, you're reasoning about the placement of the decimal and the size of your numbers. So let's get into the lesson. And this is on page 291 in my book in lesson 25. And so we will estimate. And remember, when you estimate, the answers may vary. So you may think of something that is a little bit different than me, and that's probably okay as long as you can reason it out. So I gotta roll up my sleeves for this so they don't drag. Okay, estimate the quotients. What do you do first? Round the divisor. Round the divisor first. So we're gonna take our 3 and 24 hundredths and think reasonably about a multiple of 8 that is close to, if you can't use the first number, use the first 2. Okay, so in step 1, in lesson 24, I said, oh, you're going to copy the number. Well, since we're estimating and we want to get something that's close, we're going to use the estimated number that is the buddy for this one, for our divisor. So use 3 and 20 hundredths here, and then divide by 80. Okay, so that's your rounded divisor. But we need to take this apart because, so remember all those equal signs that I said, oh, let's pay attention to the equal signs. So rewrite 3 and 20 hundredths, which you could leave as 3.2, divided first by 8, then by 10. Okay, and so in lesson 24, I said, you know, if you've got this number, you can write 32 tenths, because the 2 is ending in the tenths place, and we don't have to write 320 hundredths. So 32 tenths divided by 8 ones. And that's you're gonna solve it here. And 32 divided by 8 is what? 4, but it's 4 what? So if it's 4 tenths, then that would look like 0.4. But guess what? You have to do another step. So these really string out all along here. There's a lot going on. But we're on the other side of the equal, so now we have to do this part. So 4 tenths divided by 10 is now 4 hundredths. Okay? So we end up with 4 tenths divided by 10 for 4 hundredths. So the last one is your final answer. And I hope that makes sense, but I know the first ones are always a little bit hairy. So let's do this again, and we'll try to really look for those compatible numbers and then take it apart and then do our division. So round the divisor first, 60. Now I want a multiple of 6. Hopefully the 36 is standing out to you, but it's not just 36. It's 361. This 0.2 here, because it's so small and it's not part of that skip counting, let's take 3 in the hundreds place, 6 in the tens place, change the 1 in the ones place to a 0, and then drop that 0.2. It's just so small, we don't have to use that. As long as you get all the way back to the ones place, that can be your whole number. Now that I have a 360 divided by 60, you might recognize, gosh, they're both divisible by 10. I could simplify by doing 360 divided by 60, divide both sides by 10 to get those zeros off, then do 36 divided by 6, which is 6. And so you have kind of an easy answer on that one because they're giving you a decimal that is like irrelevant almost. Okay, so you have to reason about the placement of the decimal. Well, it would be here because we have ones. The whole thing is ones. Okay, let's do one that's a little bit harder or better for our practice. Round the divisor first, 31 to 30. Now look for a multiple of this digit that's close to 71. Well, that's not, 7 isn't close. 6 would be the closest thing, unless you know higher multiples, which it's really just easier to change this to 6. Okay, and you don't want to go up all the way to 9 because that's kind of a little bit farther and 6 is closer. Okay, now again, with the 0.00, you don't have to use that. You can do 6 divided by 30 as our new estimated expression. Okay, but take the 30 apart, so 6 divided by 3, step 1, divided by 10. Solve that for 2, but don't forget to divide by 10. And when I have 2 divided by 10, I will end up with 2 tenths. Okay, so let's do another one. Round the divisor first. And then I need something that's a multiple of 3. That's close to either 8 or 85, but 8 and 85 are both close to 90. So use 90, 85 is close to 90, and just drop off the 0.2. You want to just make things easy. Estimating is about making things easy. Now take your 90 divided by 30. Recognize that you can do the same thing that we did up in B. Divide both sides by 10 to eliminate those extra zeros, and you get 9 divided by 3 for 3. 3 ones. Here's the decimal. Reason about the placement. There it is. Plop. Okay, round the divisor first. Keep going. A multiple of 3. Look at all these 3s. I think they want you to know your 3s. Okay, and then something close to 27 and 97 hundredths. We can just use 27 and drop off all that. Remember, anything to the right of the decimal is less than 1. And if you already have 27, it's like it hardly matters. So take your 27, divide by 3, then divide by 10. Solve this first. Okay, 27 divided by 3, 9. Now divide by 10. And 9 ones divided by 10 will give you 9 tenths. Not so bad, right? Okay, now let's do number 2. Estimate the quotient in A, and then use your estimate. We're going to use what we do in A to estimate B and C. So check it out. 7 and 16 hundredths divided by 36. Round the divisor first. Round it to 40. What's a multiple of 4 that's close to 7? Well, 8 is. Now, always watch out for where the decimal is. I'm going to drop this off. I'm going to change this to 8. 8 ones. So rewrite it as 8 divided by 40. Okay, now solve according to what we did up above. You can do 8 divided by 4 divided by 10. And then 8 divided by 4 is 2, and then 2 divided by 10 is 2 tenths. So this is my first quotient. We're going to use your estimated quotient right here to estimate this one and this one. Okay, I'm not going to do any work just yet, okay, but I will fold this back so you guys can see it a wee bit better, even though we are like super smushed here at the end of the book. So I got to hold it down. It's taking all my strength. Okay, so let's check this out. What do you think you're going to get here? Look at the size of the dividend. This is 7 and this is 700. So this is 100 times greater. Okay, but it has the same divisor. Okay, so the dividend is 100 times greater. That's almost like saying 800 divided by 40. Okay, very close to that. And if I was going to, just estimate and think about this, like reason this out, I would have about 20. Now I want you to look at this quotient that we estimated. Compare it to the quotient that we got for A. Now this is 2 in the tenths place. And this is 2 in the tens place. So to shift to the ones and then to the tens place, that's a shift of 2. In fact, that is 100 times greater, right? Well, look at the dividend. The dividend is 100 times greater, and our answer is 100 times greater. 100 times greater. Okay, so it's about kind of making sense of what's happening with those numbers. When we change the size of the divisor, like in lesson 24, go watch that video. If you change the size of the divisor, it changes the size of the quotient, okay, by the opposite. But this one, if the dividend is greater, then the answer is greater. So it depends on if you're changing the size of the divisor or the size of the dividend. Now let's do another one. round the divisor first. Think about this as being approximately 80. This one's kind of in the middle. This is 7, this is 700, and this is 7 tens or 70. So if I do my simple thinking here, then I have 2 ones. So this dividend is only 10 times greater than the first one. So this dividend is 10 times greater. You can hardly read that. Lordy. E-A-T-E-R. 10 times greater than A. Okay? So this dividend is 10 times greater than A. So the quotient is 10 times greater too. Or as well. That sounds so nice. So then you're just really looking at, I'm using this, and you wouldn't, as soon as you understand this part, you don't really have to even do this. I'm just kind of proving it for you. But as soon as you really recognize what is it that's changing and how will my quotient change, then you can just kind of reason it out with your statement. Okay, I hope that's clear, but kind of an important concept. I don't know that you're going to have too many questions like that on any, say, state test or something like that. It's probably pretty high level. Anyway, let's move on with some more realistic problems. So, Edward, biking, good for him. Edward bikes the same route to and from school each day. That always makes round trip. After 28 school days, he bikes a total distance of 389 and 2/10 miles. Estimate how many miles he bikes in one day. Always watch out for the words that say estimate on, say, a test of some sort, because if they say estimate and you put the exact answer, first of all, you may not even have that as an answer choice if it's an ABCD multiple choice test, and you'll be like, oh, I can't find the answer, but I know I did the work right, and I'll say, did you read the problem carefully, because you need to estimate. So watch out for that. So anyway, 389 and 2/10 miles is the total distance, and we have 28 days, and you can make a tape diagram for that. Always 389.2 miles and 28 school days, and that's how many miles per day that we don't know, but we know 1, 2, ... and we know 28 days. So we're trying to figure out the amount per day. And so you're going to take your 389 and 2/10. That's the total. Okay. And we do know that it's 28 days. And so round the divisor first. And 389, oh gosh. So a lot of kids are going to say, round it to 400, round it to 400. And I'll say, oh no, 4 is not a multiple of 3, so you have to watch out for that. Choose a multiple of 3 that is close to 38. Think, think, think. What is close to 38? Some kids will use 300, and I would say, okay, at least we will get through this. But you could also recognize that 39 or 3 and then 9. And look at that. What if you use just 390? It's only 1 away. So you could use 390 divided by 30. And then you can use your strategy of 390 divided by 3 and then divided by 10. And so, or you can just slash the zeros off and do 39 divided by 3. That is probably what I would do. But anyway, we're trying to use this strategy. So you have 3 divided by 3 is 1, 9 divided by 3 is 3, and then 0, and then divided by 10, and we have our 13. Now, this is approximately about 13 miles in one day. Okay, so there's your answer for part A. Let's look at part B. If Edward continues his routine of biking to school, about how many days altogether will it take him to reach a total distance of 500 miles? So now we have a 500 as our new total or our whole, okay? And we're talking about the days, and roughly it's the 13 miles per day. So about how many days altogether will it take him to reach this distance? If you divide the 500 by the 13 miles per day, then again, you have options and people are going to think all kinds of different ways. If you round the divisor first, probably most people will round to 10. Some could round to 15 and do like a 450. Some kids will round this to, they'll keep this here at 500. So many different things. Again, estimates may vary. And so approximately, again, make this as easy as possible. 50 divided by 1 is 50. Approximately 50 days. Okay, and that would be an acceptable answer. How you could change it in so many ways, but you could even leave it at 13 and use a multiple of 13 if you recognize, like, say, 52 or 520 divided by 13, then you could leave that at 13. I guess I don't have to round it. So anyway, 50 days is approximately a good enough answer for that one, but just know answers may vary. And just because you don't pick 13 or 10 doesn't mean it's wrong. All right, Xavier goes to the store with $40. He spends $38.60 on 13 bags of popcorn. So about how much does one bag of popcorn cost? So let's take our $38.60 that he spent and divide it by the 13. And if we're just rounding, round the divisor first and come up with something that's close, like 40. You want to make it as easy as possible. You don't have to do 40.00. Remember, this is not as important to rewrite that. If you have 40 divided by 10, you're going to get 4, about $4. You can see this would throw people off if they had those. And I said, just take those zeros or divide by 10. People might get confused, but it's really just $4 or 4 divided by 1 for $4 per bag, approximately. And so that's fine for that, but does he have enough money for another bag is part B. And so if you have $38.60 already spent, okay, so he spent $38.60 already. So if you had to add, he would be over $40. So no, he does not have enough money for another. Okay. And so if you look at your estimate, you're using your estimate right there to explain your answer to show that he would be well over $40 by a couple of bucks. So he's going to be a couple of dollars short. So I hope these are helpful. Hit subscribe and come back again if you think they are helping you. And I'll see you on the next video, hopefully. Bye-bye.